Good afternoon, ladies and gentlemen. This video, I'm going to do the preparation problems for practice F. Practice F, and this is on page 70, page 70, and we're going to start with number 30. There's three problems, 30, 31, 32. Okay, so the first one, it says a worker drops a wrench from the top of a tower, 80 meters tall. What's the velocity when the wrench hits the ground? So yes, ladies and gentlemen, all you need to know is the height, and you'll know what the velocity is when it hits the ground. So I always want you guys to draw a picture. So here's my building, or side view of the building. There's the ground, okay? Side view of the building. And I know that it's 80 meters tall. So from the ground to the top of the building is 80 meters. So I'm just gonna draw like a little circle. And this little circle is gonna fall. Oops, I dropped it. So one thing you know in the y direction on planet Earth is the acceleration due to gravity. The acceleration due to gravity. So that's lowercase a with a little g. Acceleration due to gravity is 9.81 meters per second squared, and it's always in the down direction. Acceleration is always pointing down, so we have to give it a negative because it's going down, okay? Negative 9.81 meters per second. So if he dropped it, it's probably good assumption that there's no initial velocity. There's no initial velocity. So we say that the initial velocity is 0. All right, so the question is, what is V final right here? What is V final when slams into the ground? That's the question. Okay, so here's your opportunity now to use all those kinematic equations, except before we were in the x direction, now in the y direction. So I wrote down the first one that came to mind, V final is V initial plus acceleration delta t. Does that help me? No, I don't know how long it took. If I knew how long it took to hit the ground, then yeah, I would just use negative 9.81 meters per second squared as the acceleration and know the initial velocity is 0. So this doesn't help me. So then I go to my other one. Here we go. V final velocity squared is equal to V initial squared plus 2 times acceleration and delta y. This time it's in delta y, and we're in the y direction, so I have acceleration due to gravity. So there's my equation that I can use for this problem. And interestingly enough, I know that the initial velocity is 0, so this whole thing goes to 0. So I know that my V final velocity squared is equal to 2 times the acceleration due to gravity times delta y. Now, what's really important when you're doing these kind of problems, things falling off buildings, is the axes. So is my delta y positive or negative? I wish I hadn't drawn my picture so low, because it always starts with where you are. I'm looking for my purple pen. Where you are is where your axis is. So it's right on the ground. Here's my axis. My axis is right here. Anything above is positive, anything below is negative. Okay, so therefore my delta y has to be negative 80. That's my delta y. And you'll know if you forget that somehow you should have gotten your units to be positive, because you can't take a square root of a negative number. All right, so here we go. Let's plug it in. So I have 2 times negative 9.81 meters per second squared times I have a negative 80 meters. All right, so let's look at our units. What are our units? I got meters times meters. Okay, that's meters squared. And in the denominator, I have seconds squared. Good, because when I take the square root of meters squared divided by seconds squared, I'll get meters per second. Okay, good. So that means I'm doing good for V final squared. So I take my calculator, which is here somewhere, and I'm going to multiply 2, I'll move it after, 2 times 9.81 times 80. I didn't put in the negative numbers because I know negative times negative is positive, but you can if you want to. And I end up with a positive. So V final squared is 1,569.6 meters squared, seconds squared. Okay, meters squared, seconds squared. So how do I figure out V final? Well, if I take the square root of both sides, what's the square root of V final squared? V final. So in my calculator, I'm going to look for the square root sign. There's my little square root sign. I have to use the second button, the green button, square root. You can see the square root. And then I don't want to type up the answer. If I click on green and answer, I can get the answer. Second answer. There we go. So all that, and I do square root. What is it? I get 39.618. 39.618 meters per second. However, this is a vector. When I take a square root, I have a choice. I have the positive and I have the negative. Every square root is a positive or negative. Negative 3 times negative 3 is positive 9. And positive 3 times positive 3 is 9. So negative 3 times negative 3 is positive 9. So I know that it's going down. My picture, it went down. So the velocity is pointing down. And I have to say pointing down or I put a negative. So the final velocity is negative 39.618 meters per second. Again, it's going down because they tell you dropped it. Dropped is going down. So my vector is pointing down. So I've got to say the polarity has got to be negative. All right. So again, from any height, all you need to know what the height is, and you can figure out what the velocity is if you're on planet Earth, because on planet Earth, the acceleration due to gravity is always negative 0.81 meters per second. So all I had to do was 2 times negative 0.8 meters per second times delta y. So here's where, like, if I forget to put the negative, wait, I can't take a square root of a negative. Oh yeah, delta y is negative, and that way I get a positive inside the square root. So this is the equation for V final squared. Okay, let's take a look at the next one. The next one is number 31. Let's see, I'll zoom in so you can see what it says. All right, so we have a falcon and he dives at a pigeon. So I have to draw a picture. Remember I told you, I really want you to feel comfortable reading a problem more than once. I have a master's degree and 2 bachelor's degree, and I have no problem reading a question more than once. Sometimes you read it and you're like, sir, okay, now wait, what? You read it again. Please feel comfortable reading it again, especially if it's a long problem like this one. So we have a falcon that dives down at a pigeon. Falcon starts downward from rest, so that's important, with the free fall acceleration. Okay, free fall. If the pigeon is 76 meters below the initial position of the falcon, how long does the falcon take to reach the pigeon? And it says, assume the pigeon remains at rest. All right, so if he remains at rest, then he's probably not flying. So let's assume that the pigeon's down at the ground. Let me unzoom this now. Okay, so the pigeon is down at the ground. Down at the ground, I have this little pigeon. And up at the top, I have a falcon. Here's my falcon. Can't drop. So that's my falcon. And I know that he is, how far? He's 76 meters. So from the falcon to the pigeon is 76 meters. And it says that he starts from rest. Okay, if he starts from rest, then his initial velocity is 0. All right. And you want to know how long does he take to get all the way to this pigeon? Let's see, he's down here. Here he comes to get his dinner. And he comes and gets the pigeon who's totally clueless and not moving at all. So the question is, what is the time? Now, something they don't tell you, but you also know, is you're assuming this is on planet Earth, so the acceleration due to gravity is negative 9.81 meters per second squared. All right, so we have an equation. We want to look for a kinematic equation that has delta t. It has our y. We're going to call this delta y instead of delta x because we're vertical. But what did I tell you? When you start, looking for my highlighter, where you start, that's your axis. So here's my axis. Probably shouldn't have picked yellow. There's my axis. So from that axis, anything above it is positive, anything below it is negative. So for this guy, the delta y has to be negative 76 meters. Okay, so the first thing you want to do after you show the given and you draw a picture, and yes, I do expect you to draw a picture and write your given because you get points for that. Plus, it's just a good thing to do. Then you write down your equation. Hopefully you guys are getting that. I will not give full credit if you don't give me your equation. Here we go. Vy initial delta t plus a over 2 delta t squared. There is our equation. Now, this acceleration is always acceleration due to gravity, which we know is 9.81. Okay. We also know that the initial velocity here is 0. So this whole term right here goes to 0 because anything times 0 is 0. So this whole thing goes to 0. All right, so now I have delta y is equal to a over 2 times delta t squared. And we're asking to solve for the time, so we need to figure out what delta t is. So I need to get the delta t all by itself. How can I get rid of a over 2? Well, you guys remember multiplying by reciprocal. What is 2/3 times 3/2? It's 1. And my 2's cancel out, 3's cancel out, or 6 over 6 is equal to 1. So what I want to do is multiply both sides by this reciprocal. So let's multiply both sides by 2 over a. 2 over a on both sides. My 2's cancel out, my a's cancel out. So I end up with 2 delta y over a is equal to delta t squared. Delta t squared. So it's not going to give me my time. It's giving me my time squared. All right, that's fine. So let's plug it in now. 2, let's say you forgot to use the negative. I'm going to put 76 meters. 76 meters. And I know my acceleration is 9.81 meters per second squared. And you go, uh-oh, I end up with a negative number. Oh, look, I forgot to make this a negative 76. There you go. All right, now, I want to make sure you guys see the units. I have meters over meter squared. Let's do that. Meters divided by meter per second squared. Well, that's the same thing. I'm going to put over 1. It's the same thing as meters times, and I do the reciprocal. I flip it over. There we go. So my meters cancel out. I end up with seconds squared. It's cool because I'm getting delta t squared. Okay, so my meters cancel out. This one in the bottom, downstairs goes upstairs. So let's get my calculator. The way around here. Get my calculator and I go 2 times 7.6. I'm not going to put negatives because my negatives cancel out. Divided by 9.81. You guys can see that? There we go. So that's the square. That is, I'll write that down. What is it? 1.5494 seconds squared. That's not the time. That's delta t squared. All right, no problem. So I'm going to do the square root of this. Second square root and second answer. And what do we have? We end up with 1.24. Please let me check out. Is something wrong here? All right, make sure I did this right. Did I multiply the right numbers? 2 times 76. Try it again. 2 times 76 divided by 9.81. Oh, okay. Guys, got to check on my math here. 2 times 76 divided by 9.81. Here is 15.494 seconds squared. I really encourage you guys always type it in twice. Because there you are, you think you typed in the right number and I didn't go back and read it, see if I did the right number. I always do it twice. So there's my second squared. Now I got to take the square root of that. There we go. And answer. And what do I get? Now that's more reasonable. So therefore, delta t is the square root of that, which is 3.94. 3.94 seconds. There we go. 3.94 seconds. Okay. Let's go through this again. We have an item, a falcon that's going to take a dive all the way down to get the pigeon. And they tell you the height, the distance was 76 meters. And they say, okay, how long did it take? Well, we know the acceleration is negative 9.81 meters per second square. We know the equation is delta y, Vy initial delta t plus a over 2 delta t squared. Because our initial velocity is 0, this whole first term goes away because it's 0. I ended up with delta y is equal to a over 2 delta t squared. I wanted to isolate delta t squared, so I multiplied both sides by the reciprocal, a over 2 times 2 over a. So I end up with 2 over a times delta y is delta t squared. Plugged it in. Make sure you put in the right numbers. the calculator, because I didn't do that. 2 times 76 over 9.81 ended up being 15.494. Then I take the square root because this was delta t squared. I take the square root. Now remember, you have a choice, the positive or the negative. Well, time is never negative, so you only select the positive time. Okay, and it's not a vector, so you don't have to show positive or negative. And there you have it. It's 3.94 seconds. So we know how long exactly. It's a pretty long time. 1, 1,000, 2, 1,000, 3, 1,000, almost 4. Took a long time, so it must be pretty high up there because he didn't have any velocity when he started. Okay, the last one. The last one's the most fun. The last one, I'll read it. We'll read it together first. Here we go. A ball is thrown upward from the ground with an initial speed of 25 meters per second. And at the same instant, a ball is dropped from rest from a building, which is 15 meters high. After how long will the balls be at the same height? So we got two different things going on, and you have to draw a picture. Always draw a picture because it always makes the problem make more sense. So how did I draw the picture? The first one is the ball. Let's see, I'll draw it here. Here's from the ground. I'm going to assume that somehow you're able to throw it from the ground. We're going to call the ground the reference point. The ground, and you're going to throw it up. Shoo! And anything going up is eventually going to go down. But this has an initial velocity of, I think it's 25 meters per second. Yep. Now I'm going to put a plus because it's going in the up direction. Going in the up direction. That's important. All right, and in this case, we have our acceleration is still negative 9.81 meters per second squared. So even as it's going up, it's slowing down because the acceleration is pointing in the down direction. And then when it gets to the top, the acceleration is going to speed it up on the way down, going down. And then I'm going to say this is going to be my y. In this case here, this is where my initial here is y is equal to 0. All right, at the same time, I have a building. There's the ground of the building. And the building is, let's see, it's 15 meters high, 15 meters high. And this ball just gets dropped. Boop, it just gets dropped. So the question is, where are they both going to be at the exact same height? We don't know if it's on its way up or if we don't know if it's on its way down, but we know that the height is exactly the same. All right, so this one's going down, and I know that the initial velocity here is 0 because they said it was dropped. Or it didn't say, oh, it said drop from rest. It actually says drop from rest. Oops, there, drop from rest. All right, and then what else? And we also know here that the acceleration is also negative 9.81 meters per second squared. So after I write those two things, I always want to write the kinematic equation. Okay, so in this case here, I've got delta y is equal to Vy initial delta t minus, I'm going to go ahead and plug it in, 9.81 meters per second squared divided by 2 delta t squared. You don't have to, but I want to make sure you know really what's going on here. Okay, now here's the sort of tricky part. When you're solving for delta y, that is not telling you the distance from the ground to where it is, which is what we need because on this side is what distance from the ground up. Delta y is telling you the distance from the top to the bottom. So when you actually plug this in, let's say it gives you 3. Say it gave you negative 3 meters. Negative 3 meters was the answer. Well, negative 3 meters would be 3 meters from the top. So then it would really be 15 minus 3. That would tell me the distance from the bottom. So let's write the equation on this guy here. This guy here is also delta y is its v initial, delta t plus, again, it's negative 9.81 divided by 2, delta t squared. Okay, so this delta y is from the ground up. This delta y is from here down. That's not going to work. But if I say 15 minus whatever I have here, or 15 plus whatever I have here, then it'll be right. Now, why did I know 15 plus? Well, I go to my example. And if I say 15 plus the negative 3, okay, good, that's 12 meters. So that's why I know I want the height, the actual height here, we'll call it h. H is really going to be 15 plus the delta y, 15 plus this delta y. All right, so we're going to call this delta y1, this delta y2, that this whole story is number 1 and this whole story is number 2. Okay, so the question is, we want the height to be the same for both of them. So this height over here is going to be the same as this height over here, plus 15. All right, so let's finish filling this out. I know that the initial velocity here is 25. So this guy here is 25 meters per second. We'll leave the meters per second out. Delta t minus 9.81 over 2 delta t squared. And all that has got to equal to 15 plus all this over here. Well, let's look over here. Over here, By initial is 0. So this whole term goes out to 0. Okay, so let me write this down here. So this delta y on this guy is going to be negative 9.81 over 2 delta t squared. But the height, I got to add 15. So on this guy here, the height is 15 minus 9.81 over 2 delta t squared. And all that's got to be equal to 25 delta t minus 9.81 over 2 delta t squared. Again, the height, whatever the height is, where they both are exactly the same, over here it's going to be 25 delta t, because here's my B initial, minus negative 9.81 over 2 delta t squared. On this one here, I had to do 15 plus all this stuff. Well, plus, but this is a negative. So that's like plus negative. All this right here. 15 plus all this. Does that make sense? So 15 plus negative 9.81 over 2 delta t squared. So let me make that more clear. I'm going to put plus a negative, all that stuff. Okay, so now I have an equation here. 25 delta t minus 9.81 over 2 delta t squared is equal to 15 plus a negative 9.81. Make them both plus negatives. There we go. Now it looks the same. All right, so notice that this term is exactly the same as this term. So if I add that term to both sides, they're both going to go away. I'm going to add 9.81 divided by 2 delta t squared to both sides. Add 9.81 over 2 delta t squared. To both sides, it goes away. And I end up with 25 delta t is equal to 15. What I end up with? Ooh, that's a simple one. I want to solve for delta t. I divide 25 to both sides. So I have delta t is equal to 15 divided by 25. What is it? 15 divided by 25, and I get 0.6 seconds. So it's still a little bit more than half a second. This thing is probably still going up, and this thing's coming down, and that's what will be at the exact same height with respect to the ground. Okay, so this one was fun because it's going up, so I know the velocity is positive, but this one's going down, so I had to worry about the delta y's really from with respect from the top. All right, so hopefully that helps, and I will see you next time. All right, let's see. That's it. See you later. Bye-bye.